All right, let's get right into it. Today, we're going to talk about one of the most important shapes out there, the triangle. I mean, they're everywhere you look, but they come in all sorts of different shapes and sizes. So, how do we make sense of them all? I mean, just take a look here. Every single one of these is a triangle. They've all got three sides, three corners, but man, they look so different, right? Some are tall and skinny, some are short and wide, and some just look perfect. So that brings us to the big question. How in the world do we actually tell them apart? If you wanted to describe one specific triangle to a friend, how could you do it so they know exactly which one you mean? Well, here's the secret, and it's actually pretty cool. Every single triangle has two names. Yep, you can think of it just like a person. You've got a first name and a last name. For a triangle, its first name comes from its sides, and its last name comes from its angles. So let's start with that first name. This one is all about looking at the length of a triangle's three sides. That's it. Okay, let's meet our first contender. See those little lines? Those little tick marks on each side? That's not just for decoration. In math, it's kind of like a secret code that means all of these sides are the exact same length. And that little code gives this triangle its first name, equilateral. I mean, the word equal is literally right in there, which is super helpful, right? An equilateral triangle is just a triangle with three equal sides. Simple as that. All right, next up, check this one out. You see those tick marks again? But wait a second. This time, they're only on two of the sides. That tells us that those two sides are equal, but that bottom one, it's a totally different length. And that, my friends, gives us the isosceles triangle. That's the official name for any triangle that has exactly two equal sides. Not three, not one, just two. And for our last first name, take a look at this guy. Look really close. Notice anything missing? Yeah, there are no matching tick marks at all. That's our big clue. This one is called a scalene triangle. This is the wild card, the one with no equal sides. All three sides are just different lengths. So for first names, we've got equilateral, isosceles, and scalene. Got it? Okay, first names are down. You got this. Now, it's time to figure out the last name. And this part is all about what's happening on the inside of the triangle, in the corners. We're talking about the angles. So look at the corners on this triangle here. They're all kind of sharp and pointy, they're definitely smaller than the perfect L-shaped corner on a square. In geometry, we call those small angles acute. And that gives the triangle its last name, acute. An acute triangle is one where all three of its angles are less than 90 degrees. And that's the key. Every single corner has to be acute for the whole triangle to get this name. Now, let's move on to our next one. You see that little box they drew in the corner? That's not a doodle. It's a super important symbol in math. It means that corner is a perfect 90-degree angle, what we call a right angle. And you probably guessed it, that perfect corner gives the triangle its last name, a right triangle. A right triangle has exactly one angle that's 90 degrees. Just one. That's all it needs. And for our final angle name, check this one out. Whoa. One of its corners is really wide, isn't it? It's way more open than that right angle we just saw. It's almost like it's leaning back. Well, that big, wide open angle is called an obtuse angle. And so this is an obtuse triangle. It's any triangle that has one, and again, just one, angle that's bigger than 90 degrees. So we have the first names from the sides and the last names from the angles. Now, for the really awesome part, we get to put them together to give any triangle its full, complete identity. This chart shows how it all fits together. You can mix and match. You could have a scalene triangle that's also a right triangle. So we just call it a scalene right triangle. Makes sense, right? Or an isosceles acute triangle. But look closer. See what's impossible? You can't have an equilateral right triangle or an equilateral obtuse. And you know why? Because if all the sides are equal, then all the angles have to be equal too. And you just can't fit three 90-degree angles in a triangle. It won't work. Okay, so this is a pretty neat system for organizing shapes. But I know what you might be thinking. So what? Why do we even care if a triangle is an isosceles acute or a scalene obtuse? Well, it turns out this isn't just for math class. These names matter in a huge way in the real world. This quote really says it all. We're talking about engineering, astronomy, navigation. The strength of a bridge might depend on using a whole bunch of very specific triangles. A sailor navigating the ocean uses right triangles to figure out their location. These names aren't just labels. They describe how the triangle works, and that's what makes them so powerful. So, I'm going to leave you with a little brain teaser to think about. Based on everything we've just covered, here's a challenge. Can a triangle have more than one right angle? Try to draw one, think about why it might work or why it might not. The answer tells you something really fundamental about how all triangles work. Thanks for geeking out about triangles with me.